In the year of 1935, as storm clouds gathered over a world still recovering from the Great Depression, a small team of engineers at Grumman Aircraft Engineering Corporation on Long Island began work on what would become one of aviation history's most legendary fighters. The specifications that landed on their drawing boards that autumn called for a single-seat, carrier-based fighter that could hold its own against the best land-based opponents while operating from the pitching decks of aircraft carriers. Little did they know they were designing the machine that would stand as the guardian of the Pacific, earning immortal fame as the F4F Wildcat. The aircraft that would emerge from those design sessions possessed specifications that seemed modest by later standards but represented cutting-edge technology for its era. Standing just over 28 feet long with a wingspan of 38 feet, weighing in at 7,952 pounds fully loaded, and capable of reaching 318 miles per hour at 19,400 feet, the Wildcat was powered by a 1,200 horsepower Pratt & Amp Whitney R. 1830 twin Wasp radial engine. Armed with 6.50 caliber Browning machine guns mounted in the wings, it could climb to 10,000 feet in just under 5 minutes and operate at altitudes up to 39,400 feet. With a combat range of 770 miles and the ability to carry 2 100-pound bombs or 6 5-inch rockets, the F4F represented the pinnacle of American carrier-based fighter design when it first took to the skies. The aircraft's unique manually operated landing gear, requiring 29 turns of a hand crank to retract, would become legendary among pilots who flew it, while its rugged construction could absorb punishment that would destroy lesser aircraft. Manufactured primarily by Grumman Aircraft Engineering Corporation on Long Island, with additional production by General Motors Eastern Aircraft Division, a total of 7,885 Wildcats would roll off the assembly lines between 1940 and 1945. The aircraft served not only with the United States Navy and Marine Corps but also with the British Royal Navy as the Martlet and with other Allied air forces around the world. The F4F's combat statistics would tell a remarkable story of effectiveness against superior numbers and often superior performance. With a kill-to-loss ratio of 5.9 to 1 in Pacific operations, this compact fighter would account for the destruction of thousands of enemy aircraft while suffering relatively modest losses in return. Its pilots would include some of the war's greatest aces, men whose names would become synonymous with aerial combat excellence and whose exploits would inspire generations of naval aviators. Roy Grumman founded his aircraft company in 1930 with a simple philosophy that would guide every design that bore his name: build them tough, build them reliable, and build them to bring their crews home safely. This philosophy was born from Grumman's own experience as a naval aviator during World War I, where he had seen too many promising young pilots lost to mechanical failures and structural weaknesses that could have been prevented through better engineering and construction. The Grumman team, led by chief designer William Schwendler and project engineer Bob Hall, understood that carrier-based fighters faced challenges unknown to their land-based counterparts. They had to be strong enough to withstand the violent stresses of catapult launches and arrested landings, compact enough to fit in the cramped confines of carrier hangars, and robust enough to operate in the corrosive salt air environment of the open ocean. Most importantly, they had to be forgiving enough that relatively inexperienced pilots could master them quickly, as the rapid expansion of naval aviation would require thousands of new aviators with limited training time. The initial design requirements, issued by the Navy's Bureau of Aeronautics in 1935, called for a single-seat fighter capable of at least 300 miles per hour in level flight, with sufficient range to escort bombers to distant targets and return safely to their carriers. The specifications also demanded exceptional maneuverability, robust defensive armament, and the structural integrity to survive the punishing environment of carrier operations. These requirements would push Grumman's engineers to their limits, forcing them to balance competing demands in ways that would define the art of fighter aircraft design. William Schwendler, the brilliant aeronautical engineer who would lead the F4F design team, approached the challenge with characteristic methodical precision. A graduate of MIT with years of experience in both military and civilian aircraft design, Schwendler understood that success would require more than just meeting the Navy's minimum specifications. The fighter would need to excel in actual combat conditions, where theoretical performance numbers meant nothing if the aircraft couldn't survive the chaos and violence of aerial warfare. The design philosophy that emerged from those early planning sessions emphasized ruggedness and reliability over raw performance. While other manufacturers pursued maximum speed and climb rate, Grumman focused on creating an aircraft that could absorb tremendous punishment while remaining controllable and effective. This approach would prove prescient, as the coming war would demand fighters capable of surviving battles that would destroy more lightly built machines. The power plant selection process revealed the first major challenge facing the design team. The Navy's preference for air-cooled radial engines, based on their proven reliability and damage tolerance in naval service, limited the available options to a handful of designs from Pratt & Amp, Whitney, and Wright Aeronautical. The Pratt & Amp, Whitney R1830 Twin Wasp emerged as the clear choice, offering 1,200 horsepower in a package that combined excellent reliability with reasonable fuel consumption and maintenance requirements. The Twin Wasp's 14-cylinder, twin-row radial configuration provided smooth power delivery and exceptional durability, crucial factors for an engine that would need to operate reliably in the harsh conditions of carrier-based combat operations. The engine's air-cooled design eliminated the vulnerability of liquid cooling systems to combat damage, while its proven track record in civilian and military applications provided confidence that it could meet the demanding requirements of naval fighter service. Armament selection proved equally challenging, as the design team struggled to balance firepower with weight and complexity considerations. Early proposals called for a mix of machine guns and cannon, following European trends toward heavier armament, but practical considerations ultimately favored an all-machine gun installation. The .50 caliber Browning M2 machine gun, already proven in Army Air Corps service, offered an excellent combination of hitting power, reliability, and ammunition capacity that made it ideal for naval fighter operations. The decision to mount 6 machine guns in the wings, rather than in the fuselage or engine nacelle, reflected both practical and tactical considerations. Wing-mounted guns eliminated the need for synchronization gear, allowing higher rates of fire and improved reliability, while spreading the armament across the wingspan provided better weight distribution and reduced the risk of total armament failure from a single hit. The resulting firepower concentration, delivering approximately 4,800 rounds per minute at the point of convergence, would prove devastatingly effective against enemy aircraft. The aircraft's structural design reflected Grumman's Iron Works reputation for building indestructible machines. The fuselage employed a semi-monocoque construction technique that distributed loads efficiently while providing exceptional damage tolerance, while the wing structure used a combination of aluminum spars and ribs that could withstand the tremendous stresses of catapult launches and arrested landings. Most importantly, the entire airframe was designed with multiple load paths, ensuring that the aircraft could continue flying even after suffering significant structural damage. The landing gear design became one of the F4F's most distinctive features, though not by choice. The Navy's requirement for narrow-track landing gear to fit existing carrier deck arrangements forced Grumman to develop a complex retraction mechanism that folded the main gear legs backward into the fuselage. The manual operation system, requiring 29 turns of a hand crank, was necessitated by weight and reliability considerations, though it would become a source of both complaints and pride among Wildcat pilots. The first F4F prototype began taking shape in Grumman's Bethpage, Long Island facility in late 1936, as skilled craftsmen and engineers worked around the clock to transform blueprints into flying reality. The aircraft that emerged from the factory floor represented a synthesis of proven technologies and innovative engineering solutions, embodying Grumman's commitment to building fighters that could survive the brutal realities of naval combat. The maiden flight of the XF4F on September 2, 1937, marked a pivotal moment in American naval aviation history. Test pilot Robert Hall, a former Navy pilot with years of experience in both military and civilian aircraft, guided the stubby fighter into the air with the skill and precision that had made him one of Grumman's most trusted aviators. The flight revealed both the promise and the challenges that would characterize the F4F's entire development program. From the cockpit, Hall could immediately sense that this was no ordinary aircraft. The Wildcat possessed a solid, stable feel that spoke to the soundness of its basic design, while the controls responded predictably and smoothly to pilot inputs. The visibility from the cockpit was excellent, with large windows and a bubble canopy that provided the situational awareness essential for aerial combat. Yet even on this first flight, certain limitations became apparent that would require extensive development work to overcome. The aircraft's performance, while adequate for its intended role, fell short of the spectacular numbers achieved by some competing designs. The Wildcat's maximum speed of 290 miles per hour in its initial configuration was respectable but not outstanding, while its climb rate and service ceiling were similarly modest. However, these limitations were offset by exceptional handling characteristics and a level of structural integrity that would prove far more valuable in combat than raw performance numbers. The test program that followed the maiden flight was exhaustive and methodical, reflecting both Grumman's commitment to thoroughness and the Navy's recognition that carrier-based fighters faced unique challenges. Each flight revealed new aspects of the aircraft's performance envelope, while ground testing subjected every component to rigorous analysis. The structural integrity proved outstanding, with the airframe easily withstanding loads far exceeding normal operational limits, while the power plant demonstrated the reliability and smooth operation that would make it a favorite among pilots. Engine cooling emerged as one of the most significant challenges during early testing, as the radial power plant's heat output proved difficult to manage in the compact fighter configuration. The solution required extensive modifications to the cowling and cooling air ducting, incorporating lessons learned from Grumman's previous aircraft designs while pioneering new techniques that would influence fighter development throughout the industry. The armament installation also required considerable refinement, as early tests revealed problems with gun harmonization and ammunition feed systems. The wing-mounted machine guns needed precise alignment to ensure that their fire converged at the optimal range, while the ammunition feed mechanisms had to function reliably under the high G loads encountered in combat maneuvering. These challenges were gradually overcome through patient testing and modification, resulting in a weapons system that would prove devastatingly effective in combat. As testing progressed through 1938 and 1939, the F4F gradually evolved from a promising prototype into a mature combat aircraft. Each modification and refinement brought improvements in performance, reliability, and handling characteristics, while lessons learned from other naval aircraft programs were incorporated into the design. The result was a fighter that, while not the fastest or most powerful of its generation, possessed a combination of qualities that would make it extraordinarily effective in the unique environment of carrier-based operations. The Navy's decision to order the F4F into production in August 1939 reflected both confidence in the design and recognition of the growing international crisis. As war clouds gathered over Europe and tensions mounted in the Pacific, American military planners realized that a major conflict was inevitable and that the nation's carrier-based fighter force would need rapid expansion and modernization. The production contract called for 78 aircraft in the initial batch, designated F4F-3, with provisions for additional orders based on service experience and changing tactical requirements. This relatively modest initial order reflected the Navy's cautious approach to new aircraft adoption, but it also provided Grumman with the resources needed to establish production facilities and train the workforce that would eventually build thousands of Wildcats. The transition from prototype to production aircraft required numerous changes and refinements, as Grumman's engineers worked to optimize the design for mass production while maintaining the quality and reliability that had characterized the prototype testing. Manufacturing techniques were refined and standardized, while quality control procedures were established to ensure that every aircraft met the exacting standards required for carrier operations. The first production F4F-3 rolled off the Bethpage assembly line on February 20, 1940, marking the beginning of a production run that would eventually total nearly 8,000 aircraft. The production Wildcat incorporated numerous improvements over the prototype, including more powerful engines, refined aerodynamics, and enhanced armament systems that reflected lessons learned from both testing and early combat experience in Europe. Squadron VF-4, based aboard the carrier USS Ranger, became the first operational unit to receive the new fighters in December 1940. The pilots who first flew the Wildcat in service were experienced naval aviators who had spent years flying earlier fighter types, and their initial reactions were overwhelmingly positive. The aircraft's docile handling characteristics made it easy to master, while its robust construction provided confidence that it could withstand the rigors of carrier operations. Lieutenant Commander John Jimmy Thatch, who would later become one of naval aviation's most celebrated tacticians, was among the first pilots to recognize the F4F's unique strengths. While acknowledging that the Wildcat was not the fastest fighter in the world, Thatch understood that speed alone did not determine air combat effectiveness. The aircraft's exceptional structural integrity, reliable power plant, and devastating armament made it a formidable opponent when flown by skilled pilots who understood its capabilities and limitations. The training program that prepared pilots for Wildcat operations emphasized the aircraft's strengths while teaching techniques to overcome its limitations. Pilots learned to use the F4F's superior diving speed and structural strength to their advantage, while developing tactics that maximized the effectiveness of the aircraft's powerful armament. Most importantly, they learned to work as teams, using coordinated attacks to overwhelm opponents who might have superior individual performance. As 1941 dawned, the Wildcat was rapidly equipping Navy and Marine Corps squadrons throughout the Pacific, replacing older biplane fighters that were clearly obsolete in the face of modern threats. The pilots who flew these new machines could sense that they were preparing for a conflict that would test both their skills and their aircraft to the ultimate limit, though few could have imagined the scale and intensity of the war that was approaching. The morning of December 7, 1941, found Wildcat squadrons scattered across the Pacific, from Pearl Harbor to Wake Island to the Philippines. When the Japanese attack erupted with devastating suddenness, these compact fighters and their pilots found themselves thrust into a conflict for which they had trained but which exceeded their worst nightmares in its scope and savagery. At Pearl Harbor, Marine Fighting Squadron VMF 211's Wildcats were among the few American fighters to get airborne during the attack, their pilots struggling to reach altitude while Japanese bombers and fighters swarmed over the naval base. Major Elrod's heroic attempt to intercept the attackers with his small force of Wildcats demonstrated both the aircraft's capabilities and the courage of the men who flew them, even as the scale of the disaster unfolding below made clear that the war would be longer and more difficult than anyone had imagined. The defense of Wake Island became the F4F's first sustained combat test, as Marine Squadron VMF 211's dozen Wildcats faced overwhelming odds in defending the tiny atoll against repeated Japanese attacks. The pilots who fought in those desperate December days discovered that their aircraft could absorb tremendous punishment while remaining flyable, a characteristic that would prove crucial throughout the Pacific War. Captain Henry Elrod, flying his battered Wildcat in the final days of Wake's defense, epitomized the courage and skill that would characterize Wildcat pilots throughout the conflict. Despite facing superior numbers and operating from a bomb-cratered airstrip with minimal maintenance support, Elrod and his fellow Marines continued to launch their fighters against every Japanese attack, inflicting casualties far out of proportion to their numbers before the island's inevitable fall. The lessons learned at Wake Island, though paid for in blood, provided crucial insights into the F4F's combat capabilities and limitations. The aircraft's ability to survive battle damage that would have destroyed other fighters became legendary, while its firepower proved devastating against Japanese aircraft that had been designed with minimal armor protection. Most importantly, the Wake experience demonstrated that well-trained Wildcat pilots could achieve remarkable results even when facing overwhelming odds. The Doolittle raid of April 1942, while primarily involving Army Air Forces bombers, included F4F escort fighters from the carrier USS Hornet that provided valuable experience in long-range operations. The Wildcat's ability to maintain formation and provide effective protection during the lengthy approach to the Japanese coast demonstrated the aircraft's reliability and the skill of its pilots, while the successful recovery of most fighters proved that the type could handle extended overwater operations. The Battle of the Coral Sea in May 1942 marked the F4F's first major fleet engagement, as Wildcat squadrons from the carriers USS Lexington and USS Yorktown faced Japanese naval aviation in the world's first carrier-versus-carrier battle. The complex, multi-day engagement provided extensive combat experience for both aircraft and pilots, while revealing both strengths and weaknesses that would influence tactical development for the remainder of the war. Lieutenant Commander John Thatch, leading VF-3's Wildcats from the Yorktown, pioneered the combat tactics that would become standard throughout the Pacific theater. The Thatch Weave, a defensive maneuver that allowed two fighters to provide mutual support against attacking enemies, maximized the F4F's strengths while compensating for its speed disadvantage against Japanese fighters. This tactical innovation, born from desperate necessity in the heat of combat, would save countless American lives in the battles to come. The Coral Sea engagement also demonstrated the devastating effectiveness of the Wildcat's armament when properly employed. Japanese aircraft, designed for maximum performance with minimal weight, proved extremely vulnerable to the .50 caliber machine gun fire that F4F pilots could bring to bear. Single bursts from a well-positioned Wildcat could destroy enemy fighters that had seemed invulnerable to lighter armament, while the concentration of 6 guns made even brief firing opportunities potentially lethal. The Battle of Midway in June 1942 would become the F4F's most famous engagement, as Wildcat squadrons from 4 American carriers faced the cream of Japanese naval aviation in a battle that would determine the course of the Pacific War. The pilots who flew into combat that morning knew they were facing superior numbers and, in many cases, more experienced opponents, but they also carried with them the hard-won knowledge of previous engagements and absolute confidence in their aircraft. Lieutenant Commander John Thatch's account of leading VF-3 into the Midway battle captures the intensity and confusion of carrier air combat. We could see them coming from miles away, a great formation of enemy fighters and bombers stretching across the horizon. Our Wildcats felt solid and reliable beneath us as we climbed to intercept, the familiar rumble of the twin Wasp engines providing reassurance in the face of overwhelming odds. When we finally made contact, the sky erupted into a whirlwind of aircraft, tracer fire, and smoke that tested every skill we had learned and every capability our fighters possessed. The 4-day battle saw F4F squadrons engaged in nearly continuous combat, as Japanese and American carrier forces maneuvered for advantage while their aircraft clashed in the skies above the Central Pacific. The Wildcat's ability to absorb battle damage while remaining controllable proved crucial in the extended engagement, as many aircraft returned to their carriers with damage that would have downed less robust fighters. Ensign George Gay, the sole survivor of Torpedo Squadron 8, witnessed the aerial battle from his life raft after being shot down during the torpedo attack on the Japanese carriers. His account of watching F4F fighters dueling with Japanese Zeros at low altitude provided a unique perspective on the combat effectiveness of both aircraft types. The Wildcats were holding their own against the Zeros, trading altitude and energy for position and firing opportunities. Our pilots were using every trick they had learned, diving away from attacks they couldn't win and climbing back into position for shots at enemy aircraft that had become separated from their formations. The decisive moment of the battle came when American dive bombers, escorted by F4F fighters, caught the Japanese carriers with their decks loaded with fuel and ordnance. The Wildcats that provided top cover for this attack faced determined opposition from Japanese fighters, but their discipline and tactical skill enabled the bombers to complete their deadly work. The destruction of 4 Japanese carriers in a matter of minutes marked the turning point of the Pacific War and established the F4F's reputation as one of history's most effective naval fighters. The aftermath of Midway saw a rapid expansion of Wildcat production as American industrial capacity shifted into high gear. Grumman's Bethpage facility worked around the clock to meet increasing Navy and Marine Corps orders, while General Motors' Eastern Aircraft Division was brought online to provide additional production capacity. The lessons learned in combat were quickly incorporated into new aircraft, while experienced pilots returned from the front lines to train the flood of new aviators needed for the expanding air groups. The Guadalcanal campaign, beginning in August 1942, would provide the most sustained test of the F4F's capabilities as Marine squadrons established themselves at Henderson Field and engaged in daily combat with Japanese forces attempting to retake the strategic island. The primitive conditions at Henderson Field, with its unpaved runway and minimal maintenance facilities, tested the Wildcats' ruggedness and reliability under the most demanding circumstances. Major John Smith, commanding VMF 223 during the early days of the Guadalcanal campaign, later described the unique challenges of operating Wildcats from Henderson Field. "We were living on the edge of survival every day with barely enough fuel to get airborne and ammunition that had to be conserved for the most critical targets. Our Wildcats were taking tremendous punishment from both enemy action and the harsh operating conditions, but they kept flying. Aircraft that should have been scrapped for spare parts continued to get airborne and fight, held together by the skill of our mechanics and the inherent toughness of Grumman's design." The daily air battles over Guadalcanal became legendary among naval aviators, as small numbers of F4F fighters faced waves of Japanese bombers and their fighter escorts in what became known as the Cactus Air Force. The psychological impact of these battles extended far beyond their tactical significance, as American pilots demonstrated that they could meet the best Japanese pilots on equal terms and emerge victorious through superior tactics, training, and equipment. Captain Joe Foss, who would become the Marine Corps' leading ace while flying F4F Wildcats from Henderson Field, epitomized the aggressive spirit that characterized American naval aviation during this crucial period. His account of a typical mission over Guadalcanal reveals both the intensity of the combat and the effectiveness of the Wildcat in the hands of a skilled pilot. We would take off in whatever aircraft were flyable that morning, knowing that we might not have enough fuel to get back if the fighting went on too long. But when we made contact with the enemy formations, all those concerns disappeared. The Wildcat was a fighter's airplane, responsive and deadly, and we used every ounce of its capability to protect our ground forces and maintain control of the airspace over the island. The extended Guadalcanal campaign also provided valuable experience in maintaining F4F aircraft under extreme conditions, as ground crews worked miracles keeping fighters airborne with minimal spare parts and improvised repair techniques. The aircraft's modular construction and robust systems proved ideal for this type of operation, as damaged components could be cannibalized from other aircraft or repaired using whatever materials were available. As 1943 progressed, improved variants of the Wildcat began reaching operational squadrons, incorporating lessons learned from extensive combat experience. The F4F-4, with its folding wings and increased ammunition capacity, became the standard production model, while the FM-1 and FM-2 variants produced by General Motors featured further refinements that improved performance and operational flexibility. The introduction of folding wings represented a major improvement in carrier operations, as the space-saving feature allowed more fighters to be carried aboard each ship. The complex folding mechanism, while adding weight and complexity, proved reliable in service and dramatically increased the F4F strategic mobility by enabling larger air groups to deploy with each carrier. The Pacific Island hopping campaigns of 1943 and 1944 saw F4F squadrons participating in every major operation, from the Gilbert and Marshall Islands to the Marianas and Philippines. The aircraft's versatility proved valuable in these campaigns, as Wildcats served not only as air superiority fighters but also as ground attack aircraft, using bombs and rockets to support amphibious landings and destroy enemy installations. The FM-2 variant, featuring the more powerful Wright R-1820 Cyclone engine and reduced weight, represented the ultimate evolution of the Wildcat design. With improved climb rate and maneuverability, the FM-2 was better able to compete with later-generation Japanese fighters, while maintaining the ruggedness and reliability that had made the F4F famous. These aircraft would continue serving with distinction through the end of the war, particularly aboard escort carriers where their compact size and proven reliability made them invaluable. The Battle of the Philippine Sea in June 1944, known to American pilots as the Great Marianas Turkey Shoot, saw F4F and newer F6F Hellcat fighters working together to destroy the remnants of Japanese carrier aviation. While the faster and more powerful Hellcats took the lead in the engagement, Wildcats provided valuable support and demonstrated that they remained effective even against the most modern Japanese aircraft when flown by experienced pilots. Lieutenant Commander Edward Butch O'Hare, the Navy's first Ace and Medal of Honor recipient, had earned his fame flying F4F Wildcats in the early days of the war. His aggressive tactics and exceptional gunnery skills demonstrated the F4F's potential in the hands of a master pilot, while his later innovations in night fighting techniques showed the aircraft's adaptability to new roles and missions. The escort carrier operations that characterized the later Pacific campaigns relied heavily on FM-2 Wildcats, as these smaller carriers lacked the size and capability to operate the larger, more modern fighters. The Wildcats' ability to operate from short decks with minimal ground support made them ideal for this role, while their proven reliability ensured that small carrier air groups could maintain high operational rates even under adverse conditions. As the war moved closer to the Japanese home islands, F4F variants found new roles in the expanding conflict. Photo reconnaissance versions used the aircraft's stability and range for intelligence-gathering missions, while specialized variants carried radar and communications equipment that enabled new tactics and improved coordination with other forces. The kamikaze threat that emerged in the war's final phases placed new demands on carrier-based fighters, as defending against suicide attacks required different tactics and capabilities than conventional air-to-air combat. F4F pilots, drawing on years of combat experience, developed techniques for intercepting and destroying kamikaze aircraft before they could reach their targets, using the Wildcat's firepower and maneuverability to deadly effect. The atomic bombing of Hiroshima and Nagasaki in August 1945 brought an abrupt end to the Pacific War, but F4F Wildcats continued flying combat missions until the final day of hostilities. The last combat sortie of the war was flown by an FM-2 from the escort carrier USS Cape Gloucester, symbolically ending the conflict that had seen these compact fighters grow from untested prototypes to legendary symbols of American naval aviation. The post-war period saw many F4F variants transferred to Allied nations or converted to civilian use, while others were preserved as monuments to the men and machines that had won the Pacific War. The aircraft's robust construction ensured that many examples survived for decades after the war's end, serving as trainers, target tugs, and eventually as cherished museum pieces. The legacy of the F4F Wildcat extends far beyond its impressive combat record, though those numbers tell a remarkable story of effectiveness and reliability. In 4 years of Pacific combat, Wildcats achieved a kill-to-loss ratio of 5.9 to 1, destroying approximately 5,163 enemy aircraft while losing 870 of their own. These statistics, impressive by any standard, become even more remarkable when considered in the context of the aircraft's technical limitations and the numerical superiority of its opponents throughout much of the conflict. More important than raw numbers, however, was the F4F's role in developing the tactics, techniques, and traditions that would define American naval aviation for generations to come. The pilots who learned their trade in Wildcats carried forward lessons in teamwork, discipline, and aggressive fighting spirit that influenced every subsequent generation of naval aviators. The aircraft's forgiving handling characteristics and robust construction created a training environment that emphasized proper technique over raw performance, producing pilots who understood the fundamentals of air combat. The industrial achievement represented by Wildcat production was equally significant, as the program demonstrated American industry's ability to rapidly scale production of complex military equipment while maintaining quality and incorporating continuous improvements. The partnership between Grumman and General Motors showed how civilian industrial capacity could be effectively mobilized for military production, while the supply chain that supported Wildcat operations pioneered logistics techniques that would prove crucial throughout the war. Today, fewer than 30 airworthy F4F Wildcats remain in existence, carefully maintained by dedicated organizations and individuals who understand their historical significance. These flying monuments to American ingenuity and courage continue to inspire new generations of aviators and engineers, while their distinctive sound and appearance remind us of a time when the fate of democracy hung in the balance above the vast expanses of the Pacific Ocean. The story of the F4F Wildcat stands as a testament to the power of sound engineering principles, dedicated craftsmanship, and courageous pilots working together to achieve victory against overwhelming odds. From its origins in the pre-war design offices of Long Island to its final missions over the Japanese home islands, this compact fighter proved that success in air combat depends not on superior performance alone, but on the integration of reliable equipment, effective tactics, and skilled personnel working together toward a common goal. In the end, the F4F Wildcat's greatest achievement may have been its role in buying time for American industry and training programs to reach their full potential. The aircraft and its pilots held the line during the dark early days of the Pacific War, preventing Japanese expansion while newer and more powerful fighters were developed and deployed. This crucial contribution, measured not in victories alone but in opportunities preserved and disasters averted, may represent the Wildcat's most lasting legacy to the cause of freedom and democracy.